சுத்துதான். Hello students, all of you welcome to Future Doctor Neet Academy. Today problem solving session for chemistry. Today the topic is chemical equilibrium. So we have 7 problem here. So I am going to solve the sums one by one. Can you go to the sum? See the first question. Here in a chemical equilibrium, the rate constant for the forward reaction is 2.5 to 10 power 2. And equilibrium constant is 50. Rate constant for the reverse reaction is dash. It's a question. Okay. So here we have one small formula for that. Equilibrium constant is equal to that. Okay. Kc is equal to what? Forward reaction constant by reverse reaction constant. This is a formula, small formula. You know that. Okay. Reverse. Understood? Kf by Kr. Understood? This is a formula. Here, see the sum. Equilibrium constant, the rate constant for the forward reaction. Rate constant for the forward reaction. So it's given. What is that? Rate constant forward reaction is what? It's given what? 2.5 into 10 power 2. Understood? 2.5 into 10 power 2. Understood? By, okay. Rate constant for the reverse reaction. This only they are asking. Okay. So here keep as it is. Okay. Keep as it is. Here equilibrium constant. This is called equilibrium constant. Okay. This is 50 is given. So I write it here. So 50 is equal to, understood? 2.5 into 10 power 2 by Kr. Are you following? Okay. Now our aim is to find out only equilibrium constant for the reverse reaction. Equilibrium constant for the reverse reaction. So therefore what? These two are interchange. That I'll write it here. Therefore Kr is equal to 2.5 into 10 power 2 by 50. Understood? Are you following? Okay. Now that this 0 is cancelled, 2.5 into 10, that's what? 25. Here, remaining here 5 only. So answer is what? 5. Are you following? Answer is what? Among the 4 options, B is the correct answer. Are you following? Simple one. You just remember, this is a formula. If you know this formula, you can use to solve these sums. Just keep in mind, this is a formula. Okay, understood? Okay. Kc is equal to Kf by Kr. Forward reaction constant by reverse reaction constant. Understood? Okay. Simple one. Now go to the next one. See the second sum. For the formation of 2 moles of SO3, formation of 2 moles of SO3 from SO2 and O2. Okay. The equilibrium constant is K1. Understood? Formation, see the question, formation of 2 moles of SO3. See, how to write formation of 2 moles of SO3 means here, I'll write it here, 2SO3, okay, formation, okay. How it is formed? It is formed from SO2 and O2, SO2 and O2, then just balance the equation, 2S is there, no, 2 sulfur, so you put 2 here. I think it's balanced equation. Understood? Okay. Now, its equilibrium constant is K1. Okay. Outright the equilibrium constant here, K1 is equal to, for any equilibrium reaction, we can write the equilibrium constant. No, this is equilibrium. Understood? Okay. So, product concentration by reactant concentration. Understood? So, K1 is equal to what? SO3 power, understood? SO3 power 2 by what? SO2 power 2, then O2. Are you following? Okay. Understood? Okay. Just simply remember, product concentration by reactant concentration. That's called what? That's a way to write equilibrium constant. That is, they considered formation of SO3 is K1. Okay. Now come to the second part. Dissociation of 1 mole of SO3. Dissociation. I'll write it here. Dissociation means here dissociation means SO3 is dissociated. Okay. SO3 is 1 mole of SO3 dissociated. So I'll write it here. See, 1 mole of SO3 dissociated. 1 mole of SO3 is dissociated. Understood? 1 mole of SO3 dissociated into what? It becomes what? SO3 plus, okay, plus half O2. 1 mole they mentioned, no. Then only we should not put any number here. So SO3 is split into SO2 plus half mole of O2. Then outright, this equilibrium constant is we consider as K2. Okay, K2. Outright K2 for this product by reactant. What's the product here? Concentration of SO3. Understood? Concentration of SO3, Okay. Concentration of SO2 then into concentration of O2 power 1 by 2 divided by concentration of SO3. Understood? This is a equilibrium constant for the dissociation equilibrium. Understood? Okay. So here are you following? Okay. So the two equation is given. Now we have to compare the two equations. This is K1 value. This is called K2 value. See what's the question? Equilibrium constant for K2. Therefore K2 is equal to what? Therefore K2 is equal to, I'll write it here. Therefore K2 is equal to, okay, this is a question. Just compare. Here, just compare the two formula. Here SO3 down. Here SO3, numerator. Understood? Both are inversely proportional, no? So here SO2 in numerator, but here SO2 in denominator. Understood? Both are inversely proportional. Anyhow, K2 is equal to what? 1 by Kc. Are you following? K2 and Kc are inversely proportional, or nothing but here, okay. Are you following? When you compare the two, the two concentration, both are inversely proportional. Therefore, K2 is equal to 1 by K1. Understood? Now, see here, now if you take this one, here O2 power 1 by 2. Understood? Here, just only O2. Suppose here, if you square on this one, if you put square, then only we are getting what? See, if you take the square root of this one, we are getting this one. See, if you take the square root, if you take the square root means here put 1 by 2 will come. If you take the square root means the 2 will, there is no power here. If you put square root means there is no power here. Okay. So simply when you compare the two equilibrium, K2 will be 1 by K1 of or square root of 1 by K1. So the answer is what? C is the correct answer. Are you following? You just compare the two answer. What you remember means here SO2 in numerator, SO2 in denominator. Then only I put 1 by K1. Then here if you take the square root of this one, then only we are getting this one. Then only I put what? 1 by K1 power 1 by 2. Understood? So among the option, C is the correct one. Are you following? Okay. Now see the next one. Okay. They are given on equilibrium. They are asking to find out Kc. So any equilibrium is given means we can find out, we can write Kc. Outright Kc for that. I'll write it here. Kc. Kc is equal to what? Product concentration by reactant concentration. What's the product here? B power 2 into concentration of C2. Here no coefficient, no, you keep as it is, by concentration of A. Just remember,